Well, hey everybody, welcome to today's webinar, Avoiding Sanitation Pitfalls, Challenges and Opportunities for Your Environmental Monitoring Program. I'm Adrienne Bloom, Editorial Director of Food Safety Magazine, and I'll be your moderator today, so thanks for joining us. Now, with us today on our presenting panel are Dr. Robert Powitz, Principal Consultant and Technical Director at R.W. Powitz Associates. We also have Dr. John Butts, Principal at Food Safety by Design, LLC, and we have Joan Rosen, Founder at J.C. Rosen Resources. Now, I'll rejoin the presenters at the end to help answer your questions that come in throughout the webinar. So don't forget to submit those in the Q&A and chat section of the webinar console. And also today's event is being recorded and it'll be archived on food-safety.com so you can view it on demand and send it to your colleagues.
Good afternoon, everybody. Nice to have you here. I'm pleased to be part of this. I'm a forensic sanitarian by profession, and most of the things that I do are always at the end when there's trouble. So it's kind of nice to be asked to use what I've learned and present it to you as a prequel to the environmental monitoring program. I realize how important the EMP is, but there are certain things that I found in my career that you can do or try to do before you even start an EMP program to optimize what you have. And also optimize the expenditure because these are not inexpensive. And it also optimizes a strategy for control, particularly of contamination and cross-contamination. There are a few regulatory realities that the FDA has, and I try to look at these, and I'll give you how one looks at these collectively before you even start an EMP. The sanitation monitoring, this is monitoring sanitation practices. This is their list of things that go wrong. And these are failures to monitor and failures in practices where contamination can result. Pest management is a big one, and there we look for integrated pest management, manufacturing, processing, packing, and holding controls. This is basically the control of microbes, contamination of food, and allergen cross-contact. And then sanitation operations and plant maintenance. They found poor sanitation practices, and this is one that I found particularly egregious, is poor repair as being problematic. And finally, personnel, and there it's adherence to hygiene and cleanliness and personal hygiene practices. So with that in mind, I tried to use two good free resources that guide us through a prequel to an EMP. The first one is current good manufacturing practices. And here we're looking at the quality management, the personnel, sanitation, hygiene, validation, all the things that you normally do in your Q&A program, particularly in production. But there's another one that I found particularly useful. And this is the FDA Food Code, the current one, 1922. What the Food Code gives us, beyond the good manufacturing practices, is the definitions that we're looking for. And this goes to policy and audit as well. It gives us microbial ecology, personnel management, more specific than the GMP. And it also looks at contamination equipment and water and plumbing. And I should have put on here ventilation, not to that degree. So with the GMP and the food code, what I do next is interesting, and it's worked. It's doing a sanitary survey of the facility. In the hospital, when you're looking at patients or physicians looking at patients, What they do often with students and personnel, like nursing staff, they do grand rounds. I started grand rounds many years ago. We tried to build a team consisting of your quality control people, administration, production, maintenance. I go along as a sanitarian with, and now what we have so far, I just mentioned 5 people, that's 10 eyes, but 5 different opinions of what you see in the plant. We look at the facility altogether, maintenance and plan review, ventilation, plumbing, and surfaces. Plan review is the plant capable of actually doing what it's supposed to do safely and economically. Maintenance is one of the biggest issues. I've never been to a plant without leaks. I've never been to a plant without surfaces that have eroded or rusted. And I've never been to a plant that has had ideal ventilation or ideal plumbing systems because they've grown over time. It's not a fault of anyone. It's just the nature of the beast. We look at movement and equipment because we found, particularly with Listeria monocytogenes, that movement within a plant, and this started way back in year 2003, movement in the plant resulted in a large outbreak of LM, and there were deaths involved with it. So just monitoring the movement, mapping that out, looking then at the methods, materials, and sequence of sanitation, oftentimes because of clean in place, we'll find that cleaning one item will contaminate another or contaminate the space that it's in. Personnel, we're looking at hygiene, and here personnel movement. Are they confined to the hygienic zones? All of this as we go through. And then finally, most importantly, a policy and procedure review. If there should be problems within your plant, obviously discovery is going to come up with a policy. If you review the policy and the policy needs changing, change it. If it doesn't need changing, fine. It's a review, and there's always a question of how close do we have to stay with policy? Oftentimes, I tell a client, if you set a percentage, sometimes 90%, 80% compliance with your policy, you're going to be pretty good, and you could always raise that with subsequent inspection. So grand rounds before you even start an EMP program, environmental monitoring program, I think will not only save you money, but it'll give you an idea of where the problems are even before you embark on something. Or if you already have an EMP, it kind of clarifies your problem areas so you can target them a little bit better when you do your biomonitoring. And finally, what we try to do after grand rounds is a little thing. I wish I knew who to credit this to. It's called IDEA. Basically, what we do is in grand rounds, identify by inspecting, auditing, sampling, and process monitoring. This is a paper exercise. We define what we see through reverse engineering. We just go backwards and take things apart as much as possible, particularly the sanitation programs. We explain, and that is now the corrective end of it. And what we're looking here for are any effects or actions or consequences as a result of what we are recommending to do. And here, a word of caution. I've been in enough plants where the plant itself has gotten into trouble with the overuse of disinfectants, where being flushed down the drain, it has toxed out the local sewage disposal plant or the plant on site and basically killed off the entire biome of the plant. This is not unusual. It happens more frequently than not. So when you're looking at something that, if you identify a problem, even a problem identified by an EMP, through your EMP, try to figure out how any action that you take is going to infect the environment, personnel, or production. And then finally, what we try to do with the EMP program, or whatever we found with it, is apply the principles of contamination control, of which they're basically four. Keep them out, get rid of those that got in, and that's generally the heavy lift. Prevent damage from those that have gotten in, and then finally minimize their movement. Minimizing their movement is probably the most difficult. Most plants are put in a box, and then the equipment is moved in. And the sequence of moving sometimes may compromise movement within the plant. That's raw materials, finished product, and so on. So if you apply those principles of contamination control and go through this managing of risk just as a prequel to your environmental monitoring program, you're ahead by quite a bit. And that was basically my message. And I'm just looking at, this is nothing more than a sanitary survey. It's what we as sanitarians do anyway. And with that, I'm going to turn it over to Dr. John Butts.
Thank you, Bob. Appreciate next slide up there. So my professional career started out in the meat business and have been working in that arena since the early mid-70s, and in the early 80s. We really got engaged into pathogen control. Our early efforts took place by separating raw from cooked, as suggested by Russ Flowers in 1989. In 2000, we founded the AMI Listeria Intervention and Control Workshop. It is still active and the purveyor of best practices as preventive controls for listeria. I then spent the last 15 years consulting in both FDA and USDA facilities. So these are my observations. As Dr. Deming says, if you can't explain what you're doing as a process, then you really might not know what you're doing. So I want to challenge each of you to my slides are not showing here. Okay, I got it working here. So the first and most common problem that we see is the failure to recognize the difference between transfer points and growth niches. Surfaces that are exposed to the cleaning and sanitation process serve as points of contact as the organism is moved from its growth niche or harborage site. Transfer points should not be growth niches when effective cleaning and sanitizing procedures are used. Exposed surfaces at pre-op before production must be pathogen-free and microbiologically clean. This is a basic fundamental need and expectation. Food safety and quality must measure. This becomes a plant KPI. When positives occur on exposed cleanable surfaces, investigations must continue until the root cause is defined, eliminated, or controlled. Protected harborage sites are the root cause of persistence. Firefighting will continue until they are eliminated or effectively managed. Sanitation must be capable of eliminating pre-op positives. This is a critical factor for control. To make sure we're all on the same page, a growth niche is a location that supports microbial growth and is protected from the sanitation process. It's characterized by high microbial counts after cleaning and sanitation. A harborage site is a growth niche that contains the pathogen or its indicator. A transfer point are surfaces that are exposed to cleaning and sanitation and can serve as points of contact, facilitating the transfer of the organism from one surface to another. Transfer points should not be growth niches when effective cleaning and sanitizing procedures are used. The transfer pathway, then, as Bob mentioned, is the path of travel an organism takes to move from one transfer point to another transfer point, and eventually it is the pathway between the harborage site and the contact surface or product. This typically reflects the transfer of a pathogen by objects, water, employees, equipment, product, materials, and aerosols are all common transfer vectors. Yes, I have a problem with random sampling. For instance, let's play Battleship. You use a random generator to pick your sites, and you can even pick a few pre-selected sites and include them. I will use logic to predict my shots. Folks, bacteria just do not randomly appear. They are placed there. They are moved there by vectors in a pathway of movement. For contact surface sites and adjacent Zone 2 and 3 sites, we want a biased targeted sampling that includes selected sites from the very start of the process, entry into the RTE, until the closure of the package. When you have a positive, you want to know where that negative was at upstream. For each line, we create multiple groups of sites from which at time of sampling, a targeted group of sites are selected as opposed to using random individual sites. We also want risk-based sampling. We're not in the business of monitoring the environment, but reducing and controlling risk. We do this by controlling the production environment. To do this, we must measure and control risk. We accomplish that by risk-based sampling, sampling the most likely places where the organism may harbor or as close to that as possible in its pathway of movement of the product. The plant team must be skilled in risk identification. I think Bob did a good job of identifying that plant team. They use the principles of sanitary design as the basis for risk identification. These include wet floors, failure to effectively separate hygienic zones, raw to cook, for instance. Now, these two documents represent a total of 121 principles and 229 individual criteria elements of sanitary design. We must view sanitary design violations and deviations much the same as we view potential hazards in our HACCP plan. Recognizing the difference between verification and process control sampling is accomplished by applying some logic to our thinking process. Sampling product verifies the effectiveness of your microbiological process control. Likewise, Sampling contact surfaces verify the effectiveness of process control. If you get a positive, then your control of the organism has failed. I also believe sampling of sites in the pathways of movement is a verification measure of control. Once the organism is in an active pathway of movement, it is headed either to the product or a drain. It's just a matter of time till the product is contaminated. So process control efforts are then occur before the organism gets into a pathway of movement. Enhance sanitation on exposed surfaces as corrective action. We cannot allow ourselves to fall for this as action for a positive. This is whack-a-mole, solving the same problem over and over again. We must ask ourselves, is the exposed surface the real harborage site? Is the site under control as measured by pre-op sampling? Enhanced sanitation is an easy out. It's simply a check the box and continue firefighting. Getting 3 negatives in a row on a transfer point is not the goal. The first step after a positive is to gather evidence to determine why the site was positive. This is the seek part of the seek and destroy process. Verification comes after the root cause has been determined. Just because you get 3 negatives in a row is not an assurance that the problem has been eliminated. That's a destroy part. Cleaning and going into verification before thorough investigation is firefighting. This simply is destruction of evidence. First thing to do after notification is to initiate an investigation, prepare a hypothesis, define scope, and investigate. This means sampling. Gather data before destruction of evidence. It is most likely the positive was a transfer point, not a harborage site. Let the investigative data drive the process. We oftentimes see problems in vector sampling and what people define as vector sampling. So we must ask ourselves, how did the organism get there? Do they just suddenly appear? No, they are transported to that spot. What is our mission? To find a protected home, not the last transfer point before we discovered the organism. So investigation methods, walk around in circles. You take 5 swabs in the area, sample 12 feet around that area. Is this vector sampling? Vector sampling is following a pathway of movement from the positive site to the harborage site. We must answer how and where it came from. We cannot simply sample ourselves out of an environmental positive. Failure to use data to define the level of disassembly is one of the common problems that we find in environmental control and corrective action. Not-for-cause investigation provides data to wrong slide there, sorry. Growth niche and harborage site, it must be exposed to cleaning and sanitation. If not, then heat to pasteurize or cook the equipment is how we manage the growth niche. The procedure to identify growth niches and harborage sites is the seek and destroy investigation method, where equipment is disassembled and sample APC and Listeria. The analysis of this data is then used to define the normal level of periodic disassembly. Not-for-cause investigation and preventive control sampling is one of our keys. Failure to use not-for-cause sampling is a common mistake. The difference is, for-cause investigation is triggered with a verification positive. That's a product, contact surface, zone 3, or pathway of movement. Not-for-cause investigations provide data that define risk, new equipment, process changes, revised sanitation methods. Process control investigation is not driven by verification positive, but to enhance preventive controls. It can also be used as a part of a validation scheme for microbiological process control. We should have as many process control samples as we have verification samples. The failure to get to root cause is likewise a common problem we find in many situations. The investigation must follow product and environmental positives. 3 consecutive days of negative does not mean you've located a harborage site. Harborage sites, again, are in protected areas. They're found by sampling after cleaning and sanitization, but before production commences. Once found, they must either be eliminated or managed. Something must change. Verification then follows. So that's it from my end, and Joan, you're up next.
Well, thank you, John, and I really appreciate the opportunity to be here today and share some perspectives from the produce industry. So I thought I would start with some of the challenges that the fresh produce industry faces with respect to both listeria management and also with respect to EMPs. First point I wanted to cover was around hygienic zoning. So we are, of course, encouraged as food safety professionals in terms of food safety management, listeria management. We want to have hygienic zoning for control as well as for help in defining our EMPs. But when it comes to the fresh produce industry, that line between raw and processed, ready to eat is not necessarily as clear as it is in other industries. Rather, it is in other parts of the food industry where there's a defined kill step. Fresh produce is fresh. It's a short shelf life. It's perishable. There's no kill step. So it's important that companies have ways to segregate these areas, but it's just where that line is can be a little more fuzzy when it comes to produce. So an apple coming into an apple packing house is still an apple coming out of an apple packing house. And let's say whole vegetables coming into a fresh cut operation are going to end up as packaged fresh cut produce. So they're fresh on either side, just another challenge that we face. Another area is around older legacy equipment. Some of the operations out there have been around for a while. Some of them have older equipment, not necessarily built with sanitary design principles in mind. So that makes it more challenging from, again, both a control perspective and also with respect to EMPs and where to swab. Fresh produce operations also involve a lot of water. Water is used for transport, water is used for cooling, water is used for sanitation. And as we know, water can spread bacteria around. And also a lot of produce operations are cold. They're refrigerated. So you have this combination of cold, wet conditions, which can really help support listeria growth, allow listeria to outcompete other bacteria. So that's another challenge that's faced. And the last point I wanted to make on some of the fresh produce challenges is around where the traditional focus has been around packing house or greenhouse or vertical growing or fresh cut operations. There's been more focus, I would say, in the last couple of years around upstream equipment. And in particular, I'm talking about harvesting equipment. Harvesting equipment has been identified as a potential source of Listeria niches and Listeria growth, and there's been a real concerted effort to redesign harvesting equipment and even include it in EMP plans. I'd like to also touch on a couple of the regulatory challenges that produce faces. Produce operations can be under either the FSMA preventive controls rule or the produce safety rule. Packing houses in particular can be under either one, depending on the ownership situation. And where that is a factor for Listeria management, Listeria EMPs, is around the food safety plans. So a preventive controls rule operation facility has to have a food safety plan. They've most likely identified sanitation preventive controls that are needed. The food is exposed to the environment and it's ready to eat. So they'll likely have an EMP. They're required to have an EMP. A packing house that's under produce safety rule is not necessarily required. They're not required from a regulatory perspective to have a food safety plan. So they most likely would have one, but they're not required to from a regulatory perspective. Also, I wanted to mention around FDA's guidance document for ready-to-eat foods for Listeria control. They encourage zone 1 testing, which I think everybody agrees is important to do. But from the produce industry, it's a bit more challenging again. In fresh produce is there's no kill step, it's perishable. If you are going to do zone 1 testing, that product needs to be put on hold and the whole situation needs to be very tightly managed. Also, the test results may be difficult to interpret. If you get a positive on a zone 1, is it a transient that came through on a piece of the produce, or is it a resident from somewhere in the operation? So again, companies have to have very tight controls around zone 1 testing. And the last area around regulatory challenges is around regulatory inspections by the FDA. It has been shared within the industry that during some regulatory inspections, the inspectors have noted that if there is a positive finding in the company's EMP plan, the inspector will write that up as a failure of their food safety system. And it's really unfortunate that that has happened because, of course, the FDA is encouraging companies to find Listeria if it's there. We have, as John just mentioned, the seek and destroy approach. So companies really should be, rewarded and congratulated when they have found Listeria positives in their EMP and they've made steps to correct the situation. I think that Bob mentioned this, and I'm really glad he provided this foundation before we started around Listeria management. So a lot of this webinar is around EMPs, but let's not forget that we really are trying to manage and control Listeria as a starting point. And with all the focus on sanitation and swabbing, let's not forget that we have all the essentials that are mainly GMPs: sanitary design, traffic patterns, maintenance of the operation, refrigeration system, construction, personnel and operational practices, etc., the condition of the operation. All of these things are so important to manage to really prevent that establishment of Listeria in an operation. All right, so next what I'd like to do is turn to what I've seen over the years, whether consulting in fresh produce or also my industry experience prior to that, some of the common omissions and challenges that I've seen in EMP programs, and also some tips and recommendations. So the first one I'd like to mention is I've seen sampling programs that are not really designed to find positives. And this may be due to company culture. Maybe because they're in produce, they're thinking, okay, Listeria is ubiquitous, it's going to come into the operation at some point. I don't really want to be aware that it's coming in. I'm concerned if I get a positive, what is the FDA going to say? Or it could just be a lack of knowledge. They're not aware of what they need to do for a very effective sampling program. So 3 areas that have come up are incorrect site selection, looking in the wrong places, missing master site lists that either don't exist or perhaps are not adequate, and also a lack of flexibility in those sampling plans. So some recommendations on what could be done to address that are really revising your programs to look for those positives and have action plans. So I think John also covered this as well as Bob. Where do you expect to find that positive? You have a history of the operation, you know your operation. Get out there and walk through your operation. Go with your teams, look at equipment condition, watch practices, watch traffic flow, see what's going on. Also, I think providing samplers with flexibility to select random sites that they may happen to observe as they're going through. Maybe they have a list of 20 sites they are targeting for that day, but maybe they happen to notice a couple of others that they're a little concerned about. Well, give them that flexibility and freedom to go ahead and sample those sites. Also think about rotating days of the week in the swabbing. Maybe if you're doing swabbing 4 hours into production and Monday is your heaviest production day, maybe you'll get different results if you swab on a Monday versus a Wednesday when you've got a lighter production load. And also when you're working on your site lists, don't forget the things that move around the operation, things like floor mats, carts, dollies, forklifts, ladders, hoses, etc. All these things can certainly move listeria around or be niches in and of themselves. If you do swab those, don't forget to isolate them, put them on hold, because if you have, let's say, 30 forklifts and you swab one, you want to know which one you swabbed in case you do get a positive. The second area that I've seen as an area of concern is when there's really insufficient training and also insufficient training of the samplers and a lack of verification and coaching. It's important to remember that EMP swabbing is really different from APC or ATP swabbing. We're looking for presence absence. We're not quantifying. We want to get out there and scrub those sites and see what's out there. So some things that you can do, making sure you train your folks in the aseptic handling of the sponges and swabs, using the appropriate techniques. If you think about scrubbing your floor, if you're cleaning, you want to use that aggressive kind of a technique when you're swabbing for listeria. Using the right sampling tool for the site. If you've got a spongicle, an extension, a Q-tip swab, a rinsate, what is the right tool for that particular location? How do you access it? How do you get in there? Using Q-tips type swabs for smaller sites and sponges for larger sites. And then I think it's really important, it's something that I don't see very often, is companies actually observing their samplers doing the swabbing, making sure they're using aseptic technique, making sure they're using the appropriate technique and really looking for that listeria. Really important to get out there and do that and to retrain as needed. Also, another area, third area that I see is insufficient planning for operational changes. Whether those are special events, planned and unplanned events are often not included in an EMP, and also procedures for new or used equipment may be missing. So some things that can be done for special events, for planned events, construction, equipment installations, maybe restarting idle equipment. A lot of packing houses are idle for months at a time during the off season. Making sure you have written up in your plan procedures for doing additional swabbing during these times. And while you can't think of every possible contingency, at least have the main structure of how you want to approach this and how you want to do your swabbing. Or unplanned events. As Bob mentioned, water leaks happen, drains back up, pipes burst in ceilings. Again, making sure you have something built into your plan, an outline at least of how you're going to address those situations. Also, as new or used equipment is being installed into the operations, or maybe you're transferring equipment from one facility to another facility, making sure that there are procedures for swabbing that equipment to make sure that they're negative, they're not bringing in a problem into your operation. The fourth area that I see is really around EMP programs that do not really work effectively to drive corrective actions or continual improvement of the plan. And this has really revolved around lack of data mapping, lack of data trending, and having a very static plan, no sampling plan revisions. So again, things that can be done. Really important to map your test results. Having visual aids to do this. This can be as complex as looking at a blueprint. or some kind of a schematic, or it could be a simple hand-drawn diagram if that works for you, to really help identify the hot spots, some consistencies and where you're finding hits, and also movement of Listeria through an operation. So maybe you'll see some positives around the hand wash station, maybe the floor around the hand wash area, the positive. And if you do some swabbing along the hallway leading from that hand wash operation, you'll continue to see that Listeria moving through your operation. And also tracking and trending your results by different parameters, maybe by processing line, by location in the plant, maybe by time frame, maybe certain seasons there's a higher pressure of more Listeria coming into an operation, as well as resolving your issues, tracking what's working and what's not working. Periodically revise your plans. It's not a static program. Think about doing some kind of comprehensive or systematic or intensive baseline or verification study. And you can use your historical data for this. You can use your testing history, your knowledge of your equipment, your traffic patterns to guide you. A lot of companies will really just divide up their operation, their facility to different areas, and perhaps do intensive swabbing of one area at a time to really take a hard look and see if their A&P is really working properly or do they need to make changes. One thing that I think around this topic that's important is to remember to allow time in between these intensive swabbing events to allow for activities where you can correct any problems if they occur. You don't want to end up with so many positives that it becomes overwhelming and challenging to manage. And finally, using those results to guide your changes. The fifth area that I wanted to mention is really around laboratory expertise being underutilized. And this has revolved around three main areas: methodology selection not being discussed, a lack of SOPs for sample submissions, and then communication of results not being clear. So things that you can do: make sure you partner with a qualified, accredited laboratory. Your laboratory is your go-to partner. It's not all about the cost. It's about what value they are bringing to the partnership, to the relationship. Really important to have a conversation around methodology selection. Is the selection appropriate? Is it validated for Listeria, for the type of sample that you're submitting? Understanding sensitivity, specificity, accuracy of the test method. Also, what are the SOPs for how the samples need to be handled and submitted? How long can they stay at the facility before being sent to the lab? Do they need to be kept under refrigerated conditions? Things like that. What is your timeline for results? How are they going to be communicated? Making sure that's very clear, especially if you're going to be getting positives. Also, interpretation of the results. And a lot of this has to do with methodology. So if there's, let's say, a presumptive result with the test that you're using, that presumptive may have different interpretations based on the methodology. So really important to have that conversation up front with your laboratory to understand what method you're using and what the results mean. And finally, being aware of what options there are for whether you're testing for Listeria species, Listeria monocytogenes, or if you do get some positives, what opportunities or options the laboratory has for further genetic testing if you want to see genetic relatedness. And with that, those are my 5 areas. I'd like to thank everybody for your time and attention, and I will turn it back to Adrian.
Well, thank you everybody for that great presentation. And before we have our presenters address some of your questions, I'd like to remind you that we love your feedback, so do please take a few moments to complete our webinar survey. All right, so we've got great questions coming in. You can continue to pose questions during the Q&A here. All right, the first one I'm going to throw out, I think this speaks to Bob's presentation pretty well. So Bob, I'm going to throw this question out for you. What's your recommendation for EMP swabbing of Zone 2 and Zone 3 sites? Should you do that immediately after sanitation or during production?
Oh, believe it or not, that's a question. That's a question. Again, this is if you do a prequel sometimes and you set up your zones. When the zone is set up and you actually map out what you're doing, and you're listening to what John has said and what Joan has said, now your EMP should fall into place, believe it or not. What to sample, it depends upon what you're producing, and it really depends upon what you find in your zones. Your zones are set up obviously from clean to soiled, and they are to confine whatever is within that zone. That's one of your question is a very difficult one to answer, but if you do your homework well, now you will find, just following John and Joan's advice, it'll fall into place for itself pretty well.
Okay, great. Thank you, Bob. All right, so let's see. Lots of good questions here. This is an interesting one. So the attendee is saying many people or many companies are looking for listeria only in drains. Could you guys reinforce why this is not a good idea? Maybe John, maybe you want to speak to that. Joan, you probably have something to say about that as well.
Yes, from my perspective, a drain is a verification site. It's part of the pathway of movement. When sampling drains, we have to ask ourselves a question. Are we sampling, is the bacteria coming up from the drain, such as you have with a drain backup, or airflow coming out of that drain? If you have a normal functioning drain, then I don't want to sample down in. I want to sample the top of that and around the rim. And at that point, I'm measuring what's coming to that drain, unless the drain itself and the rim around between the drain and the flooring material is a harborage site. We're sampling stuff that is coming to the drain. So you have to, at that point, move up that pathway of movement and find where the root cause is at, or the source or the harborage site is located.
Yeah, I could just add in that to me, you're feeding the drain is the way I look at it. So I know I've been involved in situations where there are lots of positives on drains, but lo and behold, it was something feeding the drain of some equipment that was draining into that drain, and that was the source of the listeria. So yeah, certainly listeria will grow in the drains. It may be the final resting place and not the source.
Okay, great. Thanks, John and Joan.
Let me add to that as well.
Yep.
One of the things that I found, particularly on washdowns, when a hose is used to move heavy material instead of a broom or squeegee, you'll find that it'll aerosolize anything on a rough surface, and there is no such thing as a drain with a beautiful porcelain surface, and you're going to have biofilm on it. The minute it becomes aerosolized, then it'll land anywhere, as John inferred. One of the things that will be published in Food Safety Magazine, I did an article on dust. I simply use dust not as a surrogate for listeria or salmonella or anything like this, but where does it come from? And you rely then on air movement to move something from drain to a piece of equipment, or to a piece of equipment, or to another place in the shop. Doing your homework of finding what the source is, as John indicates, is probably more valuable than anything. And as Joan mentioned, a drain is a final resting place. So the last thing would be flushing the drain, but not creating an aerosol, because you've thrown everything within that drain. And the minute you hit it with a hose, and this is all wet cleaning except for some of the dry cleaning facilities like bakeries and what have you, you're going to be aerosolizing this stuff. So it's a question here of watching the clean out, the clean down at the end of the day, watching the sanitation, and then acting accordingly.
Okay, great. Thanks, all. All right, so we have a few different questions about how to select the number of swabs that you take, and swabbing protocols, especially across multiple facility location. So first part of this question is, when you're looking at the amount of swabs that you should take for your EMP, should you go off the size of the facility, or what helps calculate the amount of swabs? Let's address that first part first. I'll just throw that out to anybody who wants to answer.
I think it needs to be process and facility based. There are some equations that people have worked out on square footage, but really you're sampling based on managing risk and identifying risk. So you have to look at the risk that you need to manage and plan your sampling accordingly, recognizing that you have two choices: a verification site verifying the effectiveness of process control, and a process control indicator site, which is not in a pathway of movement, but close to the measurement of a risk site, such as seepage coming out of a floor wall juncture. That is a risk. We measure that directly, and that will then enable you to solve a problem before it gets into a pathway of movement and becomes a food safety issue. So it's really risk-based.
Let me add to that on risk. Obviously, the zoning that you have is based on risk, and it depends on your product and your movement. In setting out sites, one of the things that there's a good resource for that. The folks who make semiconductors have a very elaborate sampling plan, because here you're looking at class 1, class 5, class 10 facilities, and the letting one particle in per 5 cubic meters may cost them quite a bit. The sampling plans that they have set up, and these are again in public domain by going through the internet search, you'll see how they set it up and how they assess risk for setting up the samples. The other thing that you can use very well is your past history of what you've done already with your EMP. You have basically, as Joan indicated, if you use a good lab, they'll work with you on something like this. And then if you're looking at the high risk areas, they'll identify it. And then you may want to do a little more intense sampling. But I also, while EMP looks for the organism, this doesn't preclude using something like ATP, which looks for biological dirt. Obviously, it's very difficult to use the biological dirt to say I have so many bacteria, so many microorganisms, but it gives you an idea of where the organic material is. And that, of course, if you're looking for the classics, there's your food and your moisture. So this is how you determine. And again, if you go to other industries, and even within our own industry, clean rooms for sausage manufacturing or juice, there are sampling protocols that are used that can be quite helpful to you.
Great. Thank you, Bob. Okay, we have time for maybe one more question. I'm going to throw this one out to Joan because it's produce specific. So when you're looking at swabbing and testing for pathogens on a fresh produce production site, should you test zone 1 for pathogens, or is it better to test for indicator organisms in zone 1 and pathogens in zones 2 through 4? What's your recommendation?
Yeah, I would focus zone 1 testing for more traditional sanitation verification testing. So maybe ATP testing or APC testing to see what's happening on that surface, because also your zone 1 should be your cleanest area. It's not necessarily going to be where your niches are. So I would focus my Listeria environmental monitoring program on zones 2 and 3. And you may at some point, if you get a positive in a certain area, you may want to progress in your plan to test zone 1 for Listeria species. However, if you do that, you just need to have a protocol to manage how that's done.
Okay, great. And that actually, you answered a couple of the other questions that came through as far as sites. So thank you, Joan, for that answer. So this has been a great webinar today. Unfortunately, we've run out of time for questions, but we appreciate all those who hung on for the wonderful Q&A that we just did. And please join me in once again thanking Bob, John, and Joan for their presentations. Now, if you have any other additional questions or comments, don't hesitate to click that email us button on the console, and we'll share those with our presenters so they can respond directly to you. And if you didn't have a chance to fill it out earlier, you'll be redirected shortly to the post-event survey. We always look forward to hearing how to make our programs work better for you. And then also please make sure to visit food-safety.com/webinars, where you can find an archive of this presentation to view on demand or share with your colleagues, as well as information about all of our other upcoming events. And then also, just to remind you, registration is still open for the Food Safety Summit. It's coming up soon, May 12th to 15th in Rosemont, Illinois, and it'll give you the opportunity to connect with your peers, learn from and network with leading subject matter experts, and a lot more. So again, registration is open, so click on that Food Safety Summit logo on the bottom right of the console for more information. And as a thank you for being a valued webinar attendee, we'd like to offer you 10% off of your registration. You can use the code webinar25 at checkout. So we appreciate your time. Thanks for joining us today, and we hope you found this webinar to be a valuable experience.